let's start with that homework. Who wants to lead off with a question on any of those? The one about the tax?
Yeah, number 20.
Sounds like a popular one. Okay. What number was that? Number 20. Okay. At a price of $3 each, Yoshi, a typical New Yorker, drinks 244-ounce sodas each year. Concerned about burgeoning obesity, the mayor of New York proposes a 50-cent tax on such drinks. He then proposes compensating consumers for the price increase by mailing them each resident a check for $100. So what will happen to Yoshi's consumption of soda? Show using an indifference curve diagram with soda on the horizontal. So you want to go over the whole problem or a particular part of it? All of it?
Okay, so I put in the problem one, and mine's talking about gasoline. The exact same numbers.
Oh, really?
It's talking about gasoline.
Huh. You too?
Well, when I was looking at it, I had no idea where to start, so I was going with a solution to try to teach myself. And on the graph, it was talking about bottles of soda.
So the solution said soda, but the question said gas?
Oh, yeah, the
I
question
didn't look at the solution.
the
Let me
question
see here.
said gas, the solution was talking about soda.
But it's all the same.
It's exactly the same numbers that you just read. It's just talking
Huh.
about gasoline instead of soda.
Okay.
I don't know.
Well, that's a new one. I don't know if they changed it. I wonder, well, I think the reason it's in there, I don't know if you guys remember, but the whole thing about the giant jumbo sodas, they were trying to regulate that. Did you guys hear about that? That's part of what spurred this question, I think. I don't remember exactly when, but within the last 2 to 3 years, they were trying to ban the big 44, 64-ounce sodas and make them so that you can only buy a fountain drink in 20-ounce sizes or 32-ounce sizes or something. So they were, because there's too much sugar and too much obesity, so let's just ban soda in those large containers and that'll fix everything, you know, that type of thought. So I think that's part of what spurred this particular question. Okay, so how'd you guys start it off? Who wants to take a stab? So we're in the indifference curve chapter, so that probably helps.
Times the 3 by 200 and would be $600.
Okay, so kind of backdoor the approach that way, or at least that's spending anyway that's going on, right? So we can kind of figure out how much is going on in that regard. So at a price of $3 each, drinks 200, so when you start to set up an indifference map, we've got the optimal bundle identified. So soda, gas, whatever, I guess whatever problem we're looking at. And then we got this component. Good. $1. All right, so the information of the problem tells us we've got 200 units. And so, Blake, what did you do with, how'd you get your 600 business?
200 times $3.
Okay, so 200 times $3 is the spending going on soda. And then the slope of that budget constraint would be what? What would be the slope? What's that? Negative 1/3, right? So we got the price of what over the price of what? Price of composite soda. Price of soda over the price of the composite good. So whatever you're measuring on the horizontal axis is what goes up there. Again, this is dollars per soda over dollars per composite good. Gives me the composite over soda, which is the rise over the run if we were doing deltas here. Gives me the slope. So I always like to go back to that. I've probably done it 100 times because that's all the only way I know how to keep that straight. So if it's the, other than just point blank memorizing it, point blank, price of soda, price of composite good. Price of soda is $3. Composite good is 1. So we get a -3. Well, the price ratio is +3, but the slope is a -3. Okay, so why did your answer key do the way they did it with the y? What's going on with the intercepts there? Did you see that? So your answer keys has a, and I'm kind of getting a little bigger for my britches. Well, that's probably okay. If we had a, again, I'm not drawing it to scale, the 3 to 1 and slope and all that. If you had a y here, did you see that on the answer key? Why is that? Because the composite good's $1. So if I blow all my income, whatever it is, on the composite good, how much can I buy? Y divided by the price of the composite good. But the price of the composite good is a 1. So that just ends up being y over 1, which equals y. So that's why that is just, the intercept here is your income, whatever that number is. And then what's the horizontal intercept? Y divided by 3, because soda is $3. Okay. So we're going to, yes.
We can't assume that he spends all his income, right? Is that what we're essentially?
Yeah, we're just picking an interior solution, yes. So well-behaved preferences would give us an interior solution somewhere rather than a corner solution with his preferences. Good question. And that's generally what we'll be doing, is assuming remember what an interior solution is if we've got normal preferences with all the properties, the 4 axioms that were at the beginning of chapter 4. That's what gives us our nice convex indifference curves. Convex to the origin, the ones that kind of curve out, which means that assures us that we're going to land somewhere in the middle. Not necessarily, of course, in the middle, depending on the preferences, but generically speaking, we're going to be somewhere out there. Okay, which means there is a indifference curve that passes through this point, giving some measure of utility. All right. So after the tax and subsidy, what is our new situation, our new budget constraint? So what's going on with the question again? What's the government policy that's proposed?
There's a tax on the soda and
Tax of 50 cents and a $100 check. So a subsidy, an income subsidy of $100. So a flat tax per unit here, because this is really per gas soda. All right, so 50 cents per soda, but then a subsidy that's on your income that's just going to inflate your income. So what happens up here then? Shift up, rotate out. So now we've got income going up by 100, allowing me to buy, if I spend all my income on soda, how much can I now buy? Y plus 100. So if whatever I was making before, now it's plus 100. All right, and the new intercept down here. Now it's got 350 with the tax on it. So Y plus 100 divided by 350 with the tax. Now, probably the only thing I don't like about this problem is that the tax gets passed to the consumer completely, and I don't know if I couldn't. The mayor proposes a 50-cent tax on drinks, then proposes compensating each check roll off the consumption soda using difference curve. Yeah. So technically, they might not be able to pass the full tax on. So if we just, this is a good review from Chapter 3 stuff that you need to know for the next test that's going to be a week from this Wednesday on Chapters 1 through 5. Okay, a week from this Wednesday. So let's.
Question on that.
What's that?
Can I ask a question?
Yeah.
Is it going to be like you're doing in the micro and macro classes, or it can be online, or?
We're going to have it's going to be in class for the short answer problems. Yeah, so I'll probably do a combination of some of the multiple choice that way too. All right, so here's the standard tax case. Supply, demand, the supplier tries to charge $3.50, right? But they back off on their purchases, and so the tax is split. The 50-cent tax ends up being split between the consumers and the producers at the end of the day. And so this goes up by a fraction depending on the relative elasticities of supply and demand. We went through that elasticity formula that showed the share of the tax burden. So my point is that if we started at $3, we don't end up with the consumer paying $3.50 unless the demand curve is, let's see if this this works, but there's a couple other cases too. If demand is perfectly inelastic, but if we, actually this is not the case I wanted. Oh yes it is, no it's not. If the supply curve is perfectly elastic, then the whole 50-cent tax. But that's kind of a weird case, right? But if the supply is perfectly elastic, then the tax is all paid by the consumer. PC equals $3.50, and the old price was $3. That's a little, I would either tell you that or you need to ask or something, but that's probably one part I don't really like about this problem, is that it kind of shows the consumer getting the full tax burden passed off to it by assuming that the price is going to go up to $3.50. Okay, well that's fine. So we know the slope is going to rotate inward. And we've got the 100 out, so it's kind of doing this and shifting out. So where does that leave us? Is that what this shakes out to be?
I think so.
So how do you know that?
Well, because if it goes up to 350, and so Y is 200 gallons, 200 sodas or whatever, that would be 700, and that's 100 more than his original. What he originally spent? And $100 to pay the subsidy.
If he say that one more time. Okay.
And he got the $100.
And he got the $100 back. So, the question then becomes, would he spend it all on that, or would he substitute? Would the income change? So, the good question, good thinking. So that's how it maps out. Does everybody follow what Taylor said? So if we take the 50-cent increase at 200, right, is what you did? So we're spending, if we continue to buy 200 at $3.50 a unit, that gives us $700. But we got the extra 100 back, right? So it ends up kind of being an even Steven deal. Okay. So what would that mean then? Are we on the same level of utility or not with that amount? So we get the 100 back. We're within our budget constraint. So this kind of cuts through. We're kind of saying this, right? That point at 200 is there. Correct? I kind of drew it a little bit sloppy, but I tried to leave a little bit. Is he optimizing? Well, it is actually, but it's not quite. I didn't draw it perfectly. That's what I mean. But let's talk about it. What's going on? So, what's going on at the original situation? Tell me that. Good old-fashioned equilibrium. What's going on at the original situation? In layman's terms that you have to know for next week. So consumer optimum. See, the optimal condition is. Yep, and how do you do it? What's the condition that must hold at the optimal point? Given his budget, okay, right? So what's going on? We've got a budget, we've got preferences embodied in the indifference curve. Okay, he's getting 200 and he's acting optimally. So what's the optimal condition from a mathematical standpoint? What's going on with the consumer problem? Maximize utility subject to a budget constraint. What's the condition that must hold to know that the consumer's point of 200 here of soda star, the equilibrium point, whatever this is for the composite good, C star and S star solve that problem that he's maximizing utility subject to a budget constraint. What's the condition that must hold? We've done it at least 2-3 times. You're not connecting a dot here for some reason. What's going on here? So we got x-rays and yo-yos. What's going on at that point A? If you build on that, yes, that doesn't quite make sense to say the budget constraint's equal to the. So if I take the utility function as yo-yos squared times x to the 0.5, maybe I should do this 0.2 to the 0.5. There's the utility function equal to the budget constraint of 100. 100 minus 6x raised minus 4 yo-yos. Budget constraint equals utility function. Wrong answer. So tighten that up. The slope. Excellent. What do we call the slope of the indifference curve? The marginal rate of substitution of sodas for the composite good must be equal to the slope of the budget constraint, as Jesse said, which is equal to, you can give me more meat on the bones here. the relative price, which is what we calculated here, right? The price of soda over the price of the composite good. So the price of soda over the price of the composite good. That is the condition that must hold for the consumer optimization problem. And all we're saying here is that the slope of the indifference curve got to be equal of the budget constraint. Now that kind of brings up where this problem's going. So if I give you a new budget on this curve here that goes like this, why is that point not optimal? Because the slope of the indifference curve is a lot steeper. The slope of the indifference curve, the marginal utility of one good for the other, is a lot steeper than the slope of the budget constraint. So it's not optimal. Okay? Now, back to this problem. Taylor correctly identified that this thing rotates in around that point because we solved this thing out. We know that if, hypothetically, the person was to buy 200 units of soda, then they would be spending $600, which is just what we were spending before. So you are totally tight and sound on that. That's good. Now, how do we know that that is no longer an optimal point? Good. The budget line, it was tangent here. So again, this is where my pen was a little sloppy, and I'm going to draw it a little more carefully. It's really hard to see in the answer key too, by the way. So let me try to tighten this up here. There's no possible way that this doesn't cut through that original indifference curve. There's no possible way, right? Because we found the one and only point that is just tangent to it. And if we rotate it just a little bit, it's no longer tangent. There's only one point that's tangent, right? So it becomes more obvious here if I rotate it like this, you'll see it right away. We start to get that half moon thing, right? That half moon thing means what? What can the consumer do? What's that? Gain more happiness by doing what? We're at this point right now, point A, where we were stuck at. How can they gain more happiness? We're at 200 and whatever that number is. How can they gain more happiness? Good. Cutting back on soda. Get more composite good. Reallocate your budget. So you've got the money to do it, right? We got the money to do it. In other words, we know that there has to be, by virtue of a well-behaved convex indifference curve, there has to be another indifference curve that's somewhere out here. Now, they can't cross, but there's got to be one here somewhere, U2. And that point calls for a substitution. Composite good for soda. So that's going to lead to this new point, let's call it B, that's on a higher indifference curve, meaning they're a little bit happier. So they're going to get rid of soda and buy more composite good. The government wasn't thinking about $100 based on the subsidy, but that's one of the most important lessons in economics, is that people change their behavior with the quantity after we monkey around with price. It doesn't stay fixed. Typically, policymakers assume that's staying fixed. Well, not typically. I mean, hopefully they take it into account once in a while after economists have been harping on this for the last 200 years or so. Okay, so did we murder this problem? I think, did we answer all that? I didn't even really stay on track with the questions. What was the, part C must be a little bit different. It asks about the government, whether the government's better off or worse off. Yeah. So in terms of revenue, will the government be better off or worse off or indifferent to the proposal? Remember the structure of the policy here. 50 cents, $100 per person. What's going on with government? And at the tail end of the question says, he then proposes compensating consumers for the price increase by mailing each resident a check for $100. How is this looking for the government budget deficit? Is it going to get bigger or smaller given this? So what's the, I know we haven't been talking about macro, but deficits and spending, it's all kind of the same thing. So if we think about government revenue, that's equal to total tax collections minus total government spending, right? What's happening to this equation with this problem?
Well, the government is losing money now according to this person, but that doesn't mean that everyone's revenue is the same, does it?
Okay, that's a good question. A problem might assume that everybody's the same, okay? But as long as everybody has well-behaved preferences, so they might be a little curvier, they might be a little flatter, but everybody's got an interior solution. If everybody has an interior solution, then what can we say with certainty is going to happen to the quantity? It's going to go down. And so that's what you're saying. For this person, this problem, it would be going down, but we can argue safely, according to our model, that all consumption would be going down. Nobody would be going up because the substitution effect is always in that direction. And those are the two concepts that we're playing with here is we've, at the original amount, we've created an income effect that offset the price effect at that quantity. But then the economics tells us that people are going to substitute because we stayed on, there's an indifference curve that is above it. That must be true according to our mathematics and our graph. There's an indifference curve that's higher. There's a higher level of utility by getting rid of some soda and getting the composite good. Okay, so whatever this number is, if this drops to 180, to 190, you pick a number, it's got to be something less. Now, this isn't making up the difference any longer. The government's collecting less money than what they're paying out because they're going to continue to pay out 100. And so the 100 is going to stick over here, and we're going to have something less over here. We're not going to get the 50 cents. It's going to be, because this little tax revenue function was T times QT, if you will, the quantity after the tax. And that is 50 cents times something now that's less. If it happened to be 190 minus 100, then we've got, 95. 95 minus 100 gives us a $5 deficit. Here we go down the rat hole that we're continuously in Congress in the United States, right? Spending more money than what we're bringing in. Okay. Any other questions on this? This was a good one to dissect. I hope you're pulling stuff out of here that'll apply to other problems too. Taylor.
I don't want to complicate it too much, but
Okay.
would it make a difference? Because obviously this is gasoline, and we talked about gasoline being a different kind of good because it's relatively
Inelastic. Yeah.
So I didn't know if that would make a difference in the problem at all.
What it would do is that some consumers, if they're perfectly inelastic, might not care. But there's always people, so if we had Tom, Dick, and Harry, and Tom's look like this, and Dick's look like this, it's pretty steep, but it's not perfectly steep. And then somebody out there was kind of poor, and they're like, I'm going to ride my bike. I'm going to carpool with my friend. I'm going to start seeking alternatives for riding. Again, in the market, there's going to be a reduction in the quantity. And so that preference structure for gasoline changes the shape of your indifference curve. And so if we do a rotation, if we put less curvature into it, then there's not going to be very much movement off of it.
But there still will be a little bit.
Yeah, unless the indifference curves were, perfectly, yeah. Okay, but that wouldn't happen in the aggregate anyway. But for a particular individual, their preferences could look something like that. All right, anything else on this problem? Okay, so other problems. That was just one. We spent a good half hour on one problem.
I showed a little bit of 14, just kind of with numbers, I guess.
Okay. Number 14. What is this? Red beans. Consider the following diagram, which illustrates Gaston's preferences for red beans and rice. Gaston has income of 20, rice is $2. Derive Gaston's demand for red beans. Okay, what did you struggle with?
Giving numbers to the graph.
Okay. And just making it kind of line up good, or what? So, with a problem like this, we're creating a demand curve. And changing prices, I assume. Is that what? Yeah, use your prices of 2 and 4 in your analysis. So I guess the things that we need to fall back on are the basics for prices and quantities. So we got red beans here and rice. We call it RB, red beans and rice. And with this type of problem, and you might see later some problems that we can use a computer to do a budget constraint too, with a graphing tool and that sort of thing. When it's at one price or the other. So this one we went 4 to 2. I don't know if we're going down or up, or if it really matters. Prices of 2 and 4. So endpoints are always income divided by the price of rice. These endpoints are always income divided by the price of red beans, which again, all we're doing is saying, suppose I spend all my money on one good or the other. So that gives you your anchoring points. And then if you're really graphing it out, graph a straight edge. With this particular problem, you might want to put it right on. Oh, I guess I'm looking at the answer key. No, I'm not. Yeah. So in this problem, they gave that to you in there if you printed it off or whatever, to try to get that lined up. So having these basics, where we had a $20 and then the price was $2 and then the price was $4. So income divided by $4 puts us over there. Does that help, or is that kind of what you're?
Yeah. I think it threw me off with just trying to let the utility curves.
Because they gave you the utility curves without the budget constraint, yeah. And so, yeah, having these out here to begin with, and then they kind of gave you the points where they would fall. So they were kind of trying to give you helpful eyeball tips, I think, right? I'm guessing that's where those points are. Okay, does that help enough with that?
Yeah.
Okay. Other questions? Yeah.
Okay, 13E.
Carmen's preferences are such that she is always indifferent between watching 2 movies or seeing 1 basketball game. What must the indifference curves look like is A. And then suppose that Carmen has an income of 90. If movies cost 10 and basketball games are 18, what will be Carmen's optimal bundle be? Yeah, these are kind of interesting. So are those perfect substitutes or complements? Perfect substitutes. So I don't know if there's an easier way to do this or not, and it I think helps to have multiple colors. I think it's probably good to draw the indifference curves first. And I don't know which one you drew first, but the indifference curves, what do they look like? Straight line, right, with a 2-to-1 trade-off. Did they tell us where to put what? Okay, well, it doesn't really matter. How did you put them, Taylor?
I didn't.
Oh, you didn't? Okay. I would draw a graph, and then, again, it doesn't matter. What are the two goods? Basketball game and movies. And we always want, what, 2 movies for each basketball game? So 1, 2, and 1. So 3, 4, 1. Okay, and that might even be enough to get you started. So this would be U1, U2. We're getting happier as we move out. 1, 2, maybe I'll do one more. And 1, 2, 3. You with me on that? Okay. Now, what is the budget constraint slope? And this might be part of your issue, Taylor, judging by your response to the last problem. What is the slope of the budget constraint generically? Price of movies. Blake has got this one down. Or the price of basketball tickets. Okay? So we know that in equilibrium that needs to hold for well-behaved preferences equal to the slope of the indifference curve. That's not going to happen here because this is a weirdo case of perfect substitutes. But price of movies were what? $10? 10?
Yeah.
Okay. And basketball was 18? Okay. And what is this? Then we got 1 over 1.8. So what is that equal to there? 10 over 18.55. All right, so slope of the indifference curves is what? So the marginal rate of substitution for movies and basketball games is, what's the marginal rate of substitution? -1/2. So now I just want to caution you on that. So this particular time I asked what the marginal rate of substitution is, not the slope. A little bit of a, I'm not going to try to catch you on that, but I want you to be cognizant of it because it's kind of important. When you start thinking about it conceptually, the marginal rate of substitution here is 1/2, which means the slope of the indifference curve is -1/2. So that's okay. And then we've got a 0.55 slope of the budget constraint. So is that steeper or flatter? That's always the key part next. 0.55, steeper or flatter? Steeper, right? So the rise over the run, if you go back to the basics, this over 1, this over 1, we're going to be rising or actually falling in this case a bigger distance than what we're running. So let's be obnoxious about it. If we're obnoxious about it, then how can we be made better off? Let me just draw this one. I'm just going to be obnoxious about it here and go like this. If we're currently at, I'm just picking a point, we're spending all of our money at U2, how could we be made better off? Less movies, more basketball. And we're going to, so this would make us better off. So B would be preferred to A, but we can even do better. We can drive ourselves all the way out to an indifference curve that's out here at 4, which is our optimal solution, which is a corner solution, not an interior solution. And so we're going to buy all basketball and no movies. Okay? I don't know why the temptation is, but it's sometimes for me too to go to the wrong good on that. But it's kind of the way your eye treats it, because you're able to get to higher utility by having the utility out further. But for some reason, my eyeball kind of wants to bring me down to here and keep the budget constraint outward. So you kind of got to keep those two rolls right, that we want the indifference curve out as far as possible for a given budget constraint. Okay? All right, other questions on the homework? Any other ones?
Last one we kind of just did.
Yeah.
Could we use, to get to the 5 basketball games, I guess I kind of looked at it with like the budget line using, how many.
Yeah, I guess
Utility.
did they give us a 90? Oh, yeah, we had a 90. Sorry. Yes, I would have drawn the 90.
Okay.
I did it kind of generically up here. So yes.
Budget line that we would have fixed with the 90 and whatever.
Yes, I would have fixed.
Movies would have been for the.
Yep, you're doing it right. I kind of just overlooked that 90. So with the thing that's a little more difficult with that maybe is to figure out which endpoint you're at. But if we went to all movies, and movies was down here, we could go to 9 of them then, right? And if we went to all basketball games, 5. Okay, now we've got our budget constraint, and let's make ourselves as happy as possible, but then you got to figure out that the indifference curve is steeper. Is it steeper or flatter? That's where I think my brain starts to get weird. Right? It's actually flatter.
Yeah.
So that we get the same answer we did up here, but yeah, go to all 5. But you have to work through this logic first, the slopes, which one's got the greater slope. Okay. Other questions on the homework?
Number 5, looking at substitution versus income effect.
Okay.
I wasn't really sure where to, like, look, I have my graph, but I don't know which one necessarily.
Okay.
Looking at my graph, I would have got income effect instead of substitution with the max out.
Okay, what is it? 3 to 2. You know, it's almost, well, you guys, well, maybe not. Let me try doing this on the board. I was going to maybe bring down the screen, but by the time I do all that, I can probably draw it at least enough to.
So is the income effect always going to be on the left?
My gut feeling is no, but I'm not quite visualizing that whole thing. Well, I don't know what you mean. The left of the other optimal point?
Yeah.
No, the income effect can go either direction because of inferior good and, let me pause that. All right, what is this thing here? Rice and pasta? And we've got one like this and one like this. And we've got an A up here. And we've got a B down here. Not too bad. For a quick one here, right? All right. So Jesse, you're wanting to know, we went from, there was a price increase apparently in pasta, right? Because we were made worse off. So we went down like this. All right, so the total effect, first of all, the total effect is from 3 to 4 for rice. So we had a 1 unit change. And now we're going to try to dissect that by taking the new prices, which is this one, and going back to the old indifference curve to find what the substitution effect was. And so in this case, the substitution effect, wherever if I drew a nice curve here, maybe it's out here. Is that the way the book ended up? So we're somewhere over here. So this is kind of our little, I don't know if you want to call it B prime or C or whatever it is, but there's your substitution effect. And then the income effect is coming back this way. So if this is, did it come out to be about 6? Looks like it did according to the book, but I didn't draw the scale very good, but is that what you guys got? Or to 5? I guess to 5 looks better, doesn't it? Again, you just kind of eyeballing from the book, but so we had a substitution effect of 2 units, and then the income effect brings us back from this point all the way back to where we end up, which is at 4. So we had a 1 unit income effect, and we had a grand total effect from 3 to 4. The total effect is always the new budget and the new indifference curve. So you always got hopefully the total effect nailed down. And then we're trying to break it apart. I gave you that list last time of take the new prices, go back to the old indifference curve, making that new tangent point. The movement along the old indifference curve is always the substitution effect, which makes sense if we have, with the prices getting higher, we're reducing our pasta purchases and we're increasing our rice purchases. And then we've got the income effect is the rest of the way from that point back.
Now to get your B1 point, would you, like you did the other day, hypothetically move your, the budget line up?
So that's the income effect is coming back from B prime to B is the income effect.
But I mean, like, we move that line up to get a tangent to
Yes.
the point. Is that kind of how you look at it to find that utility point?
Yes, to find B prime?
Yeah.
Yes.
Okay.
And so back in your notes, that was, I don't know what step I had, but take the new prices and bring them back to the old utility curve, the old indifference curve. Okay, other questions on that one? All right, we'll call it a day there. I want you guys to hit your homework for tonight and tomorrow, or for Wednesday, is to do the Chapter 5 learning curve. Now that we've gone through the material, let's see how the learning, I kind of did it in reverse.